So this video is notes on oxidation and reduction reactions. So first thing is that oxidation is losing of electrons, or it's also gaining in oxygen. And this usually happens when you are burning something or when you see something rusting, that kind of brownish color you see, that is an oxidation. And a reduction is just the opposite of that. It is gaining electrons or losing in oxygen, okay? They are opposites. So when you kind of put them together, they kind of balance each other out. You can't have one without the other. And so together, these reactions are called redox reactions for short. So the RED is for the reduction part, and then the OX is for the oxidation. So redox for short. There's a really nifty thing here of how to remember oxidation and reduction. So as you can tell, we have this lion here, okay? His name is Leo, L-E-O. And what do lions say? They say GER, G-E-R. So whenever you need to think about oxidation reaction reactions, think of Leo, the lion, says GER, okay? Leo stands for losing electrons is oxidation. And G-E-R, gaining electrons, is reduction. So Leo, the lion, says GER. So during these chemical reactions, all reactions are just when electrons are being transferred or moved back and forth. That's why things change color and do all this different stuff. So really one element gives something to another. That's what these redox reactions are going to be. So let's look at a quick example of some electron movement. If you have magnesium is reacting with sulfur, magnesium is going to end up with a 2+ charge, and sulfur is going to end up with a 2- charge. And those charges are just what they want to be, just like on the periodic table. So magnesium becomes magnesium 2+ because it lost those 2 electrons. So that's shown in this little thing. It's called a half reaction. Okay. And then sulfur ends up gaining those 2 electrons and becomes sulfur 2-. So remember from a while ago, when you gain electrons, you become more and more negative. Okay, when you lose electrons, you become more and more positive because you're getting rid of the negativity. So when thinking about this, we think of Leo the lion says GER. So magnesium lost electrons, so that's oxidation. Sulfur gained electrons, that is reduction. And you can use RED for short or OX for short, just to kind of save on time there. So for today, we're going to be assigning oxidation numbers to different elements. And basically, this is going to help us keep track of where electrons are going. Okay, so what is an oxidation number? It is a charge that is assigned if the electrons are given to the more electronegative element. Okay, so you might recall electronegativity from like forever ago. Okay, this section over here on the periodic table are things that have really, really high electronegativities. That means they really, really want electrons. One way you can tell is it's usually going to be the second element in an equation, or it's going to be whatever the last element in an equation is. That's going to have the highest electronegativity. All right, so we have about 5 rules for oxidation numbers, and then I'm going to do some examples. So first rule, oxidation numbers of ions, the oxidation number is going to be the charge of the ion. So for example, if I have nitrogen that has a 3- charge, then the oxidation number is going to be 3 minus. Okay, rule number 2. If the oxidation number of hydrogen is going to be equal to 1 plus or 1 minus. It kind of depends on what it's bonded to. More often than not, hydrogen will be 1 plus, but sometimes it'll be 1 minus too. It just kind of depends on what it's bonded to. Rule number 3, the oxidation number of oxygen is going to be equal to 2 minus, and that's just from the periodic table, but that's unless it's in a peroxide. So what a peroxide is like something 2O2. So anytime you see something 2O2, that's a peroxide, and in that case, the oxygen is going to be 1 minus. Rule number 4 is that the oxidation number of an element when it is alone by itself is going to be equal to 0. So for example, if we have just potassium, that's 0. Aluminum, that's 0. But even if you have something like O2, that is still an element bonded to itself, so it's really alone in this case. So that would be 0 as well. And rule number 5 is that the sum of oxidation numbers is going to be equal to 0. I'm going to bold that one because that one is very important. There is a 6th rule here too, actually. The sum of the oxidation numbers could also equal the charge of the entire compound. So for example, if we have like PO4 with a 3 minus charge, in that case, the oxidation numbers will add up to 3 minus rather than adding up to 0. All right, so those are all the rules. Let's do some examples. So first example is H2. That's by itself, so that means the oxidation number here, it would just be 0. Same thing if you have something like Cl2 by itself, just going to be 0. Or if you have something that's just carbon, that equals 0. Okay, if it's alone, it will be 0. So let's say we have something like CO2. So each of these numbers, the carbon and the oxygen, will both need a oxidation number. Oxygen is the most electronegative thing, and oxygen is going to be equal to 2 minus. And that comes from the periodic table based on what column it's in. So oxygen is 2 minus, and we have 2 of them. So I'm going to multiply that by 2. Okay, so we want to know what carbon is. So carbon's going to be this X, and this has to, the sum is equal to 0. So we got X plus -4 equals 0. So what should the X be? X has to be 4 plus. Okay, if you just put 4, that's technically wrong, so make sure you include 4 plus. Okay, they have to add up to 0 here. Okay, second example, if we have CO, in this case, oxygen is still 2 minus. So now carbon must equal 2 plus to add up to 0. So the oxidation number can change based on what it's bonded to. Let's look at CH4. So hydrogen is most likely going to be 1 plus. So that means we have 1 times 4, right, equals 0. And we want to know what our X is. So if X plus 4 is equal to 0, that means carbon must be 4 minus. So you can kind of see here, carbon can be 4 minus, it can be 4 plus, or it can be 2 plus. It just kind of depends on the situation. All right, let's look at another one. Let's say we have CO3 with a 2 minus charge. Now this one is not going to equal 0. It's going to equal 2 minus because that is the total charge here. Okay, so oxygen still going to be 2 minus. So I get 6 minus because 2 minus times 3 is 6. So what is our x going to be in this case? Well, if x is 4 plus, that would solve this equation. All right, so let's look at Na2O2. Now this one, warning, this is a peroxide. It has something 2O2. That is the case where oxygen is not going to be 2, it's going to be equal to -1. So we have -1 times 2 is equal to 0. And this time, our x actually there's 2 of them. So it's not just going to be x, but it's going to be 2x because of that Na2. So now we just need to solve for x. Pretty simple algebra equation here. So we get 2 plus on one side is equal to 2x. Therefore, x must be equal to 1 plus. And I know it's kind of weird. The oxidation charge goes after the number. So like 2 minus. You can just think of that as like -2. All right, so let's look at KMnO4. So always do whatever's in the middle last. That's usually the easiest way to do it. So oxygen's 2 minus, so total there is 8 minus. Potassium is going to be 1 because it's found in this first column of the periodic table. So everything in that first column is always going to have an oxidation number of +1 because that is its charge. So we have 1 plus x plus 8 negative equals 0. So that means we have x plus -7 equals 0. So that means x must be equal to +7. So those are the oxidation numbers for K, manganese, and oxygen. So a couple more examples. We have calcium fluoride. So calcium has a charge of 1 minus. So that comes from the periodic table, which means calcium has to be 2 plus. Okay, next we have S with F2. So fluorine's charge is 1 minus again. But sulfur here, you can't always follow the periodic table. In this case, sulfur has to be 2 plus because it's giving its electrons to fluorine. So even though it's with oxygen on the periodic table over there, just you have to look at what it's bonded to. So it's not always going to be the charge. That's what makes oxidation numbers different. Okay, last one is going to be a challenging problem. So let's say we have NH4, we have 2 of those ammonias, and then oxygen. All right, so we know that oxygen is going to have a 2 minus charge because it's not a peroxide, just a regular old oxygen. So then looking at this 2, it distributes to the N and the H, right? So we're going to have 2X, that's going to be for the N, and then we're going to have 8 of these hydrogens. So I'm just going to use Y for the hydrogen. So 2X plus 8Y plus 2 minus equals 0. Well, hydrogen is normally 1 plus. Okay, that's pretty typical of hydrogen. So I'm going to make this 8 plus for these hydrogens. So now at this point, you just got to solve for x. This is an algebra problem. So we get 2x plus 6 plus equals 0. So we're going to minus 6 on both sides. So 2x equals -6. Divide by 2. X is equal to 3 minus. So n is equal to 3 minus.